Hi guys, I want to take a second and have a little chat about fractions. Fractions are the bane of our existence, I would say. Nobody likes fractions. Why would you like a fraction? It's crazy, wow. But let's just take a second and think about these things. They're not as bad as you might think. So let's take a couple of fractions, for example, and let's start off with multiplication first. So if I had two fractions like this, multiplied by 2 over 3 multiplied by, I don't know, 4 over 5. Multiplying fractions, basically, is probably the easiest thing in fractions that you can do. And all you have to do is take the top, which is called the numerator, but what is the numerator? I hate big words. The top times the top, so multiply here, and the bottom times the bottom. Multiply that in there. And then you get a new number like this. 2 times 4 gives you 8. And 3 times 5 gives you 15. And that's multiplication. Wow. Okay, so there has to be something harder than that. Definitely, because I remember fractions back in school, they were hard. So let's try division. That could be harder. So division, let's use the same numbers. So okay, 2 over 3 divided by 4 over 5. This has to be challenging. Well, not so much when you think about it, because we already know multiplication is really easy. So we just take the 4 over 5 and flip it. Like this. I like to do this because I can. It's kind of, so flip. Well, pen. Oops, I can't spell this morning. So flip it. What I mean by that, it means take the reciprocal. I use small words instead of big words. Big words are crazy, so take the reciprocal or just simply flip it upside down. So by doing that, we hit like this. We have 2 over 3 multiplied by 5 over 4, flipped upside down. And we already looked at multiplication back here, and that was easy. And now we're doing multiplication again. It's pretty easy. So we have 2 times 5 is 10. And 3 times 4 is 12. Alright, nice, easy. But look at this and we say, okay, this is a little different because the number on top and the number on bottom are even. Can we make them smaller? When you give the fractions, you've heard the term reducing before, and all reducing means taking the fraction and turning it into a smaller fraction. But that means the same value, of course. So before we get into that, let's talk about this concept right here. We all know that 5 equals 5. For example, this sounds kind of silly starting out, but let's look at it another way. 5 over 5 equals 1. So, and 1 times anything is just the same number. 7 times 1 is just 7. So basically, we have something like this. It's just a 1. So let's look at the fraction that we have here, 10 over 12. Let's think more about it. So 10 looks like this. 10, we can express 10 as 5 times 2. Okay, no problem. That's still 10. We can express 12 as 6 times 2. No sweat. What you notice, before you can do this, I'm going to do, I'm really breaking this down simply. I'm going to just take this, I'm going to just draw a line down here, and now you'll see the connection with over here. So now I'm breaking those two pieces apart, and I'm going to say, okay, it's going to be 5 times 6 times 2 over 2. And based on what I know over here, 2 over 2 is just going to be 1. 5 over 6 multiplied by 1. And we know now that's just going to be 5 over 6. It just makes sense. And that's reducing. You ever think it could be so easy? Okay, so there has to be a situation where fractions get hard. Because I remember back in the day, struggling with fractions, they get hard somewhere. They definitely get harder. Okay, let's see how they get harder. Let's try another page here. So let's take the same equation. Actually, no, we won't. So let's try adding them. And adding them and subtracting them are pretty much the same process. So if I have something like this, I have 2 over 7 plus 3 over 7. And the bottoms are the same, or when the denominators are the same, I just add the top. So add the top, 2 plus 3 gives me 5 over 7. Oh, that was very challenging. I don't know how I managed like that when I was in high school. Alright, so it has to get nasty somewhere. We all know that. These are fractions. They gotta get nasty. What about if I have something like this? 1 over 2 plus 1 over 3. Oh, now we're talking. The bottoms are different. We can't even begin to try to do that one. Well, let's have a look. I want to start on the page. Let's have a look at it closely. What I want to do here, for example, start out with some circles. I'm going to make a bunch of circles. Hang on a second. This will all make sense in a second. So I'm making these circles here right now, and like this. I'm going to give me some more room here. Move this down a little bit. So now let's begin with circles. So we're looking at adding these two numbers here. Looking back, let's say 1/2 and 1/3. Okay, so we're going to add 1/2 and 1/3. Let's put down here. So 1 over 2. 1 over 2 plus 1 over 3. Now, let's have a look at these circles here for a second before we get too crazy with this. I'm actually going to come down here and rewrite this out a little bit more because I have a plan. Whoa! Bye-bye. So we're going to have 1 over 2 plus okay, 1 over 3. Okay, so let's check something out here. Good. And we're good. So now up here in the circles, let's have a look at these circles and let's say what I'm going to do here is take the circle, take that off, and what I'm going to do is divide the circle. There we go. And I'm going to divide it into 2 pieces, like that. I think the first piece here, I want to color it. Let's use a nice color. How about blue is fine. So you see that 1/2 of the circle is now shaded. Okay, so let's have a look at that. So down here I'm going to put down 1/2. You see there's 2 pieces, and one of those pieces are shaded. Let's look at the other circle over here. The other circle over here looks like this. I'm going to divide that circle into 4 pieces. 4 pieces. What I'm going to do, I'm going to shade these 2 pieces here. And you can see that now 2 pieces out of 4 pieces are shaded. So we have 2 out of 4 are shaded. Let's look at the next circle. Oops. Next circle says we have, let's say we have 6 pieces. Here we go. And what I'm going to do now, I'm going to shade 1, 2, 3. So now we see that three pieces are shaded out of the 6. So we have 3 shaded out of 6. But if we look at the circles closely, you can see that this circle is equal to that circle, which is equal to that circle. All of these circles are the same size, you saw me do it. They all have the same shaded area, which means they all have the same value, they're all equal to each other. Which means that 1 over 2 is equal to 2 over 4, which is equal to 3 over 6. This makes sense, right? These are what's called equivalent fractions. So, why do we do this? Well, we'll figure it out now in a second. Down on the bottom here, so look at the bottom section. I'm going to take that one and divide it into 3 pieces. I'll use a new color on this one so we don't get confused. Let's use red. And what I'm going to do, I'm going to shade one of these red. So we can see that there's 3 pieces there and one is shaded red. So that means 1 out of 3 is shaded red. Sweet. Alright, what's the point here? Well, let's keep going. The point will become obvious shortly. So let's have a look at this. I'm going to do the circle. I'm going to take this circle and change it again. Right here. I'm going to change this one into 6 pieces. You see our 6 pieces. What I'm going to do with this piece, I'm going to shade this one and this one. And you'll notice the shading is exactly the same size as before, but now when we look at the numbers we're dealing with, we have 2 over 6. So 2 pieces are shaded out of 6, but you see the same area is shaded as in the previous circle. So let's try one more. Over here, what we're going to do is the next circle is going to be right here, and we're going to take this and divide it into, let's say, 9 pieces. Nine pieces looks like this. But what I'm going to do right here, and just to show you, I'm going to go 1, 2, 3. And once again, you see the same area of the circle is shaded. And what does that mean? That means that we have 3 shaded pieces out of 9 total pieces. So as same as before, you'll notice that all these shaded areas are exactly the same size. So these shaded areas are equal, that's equal, and that's equal. And therefore, if those pieces are equal, then these fractions must be equal down here. So in other words, 1 over 3 is equal to 2 over 6, which is the same shaded area. There's no math involved with this, it just makes sense, right? This is pretty cool. So now, down here, let's switch down a little bit more. No one probably showed you this kind of trick, and because I have the technology, I can do this kind of trick. Let's look down here. We have 1/2 plus 1 over 3. And we know that we can't add those together. Everybody tells us you can't add fractions when the bottoms are different. So let's make the bottoms the same. Oh no, now that means it's big trouble, because now we have to find a lowest common denominator, and first of all, I don't even know what the denominator is, and I think I broke one on my car last week, but whatever, it's expensive for sure. It's just my sense of humor, sorry. In any case, we'll make the bottoms the same. So, how do we do that? Well, up here you notice that we were saying that 1/2, this number here, is the same value as this number here. So why not use it? You're thinking like, what? Okay, well, what I'm going to do here is take this number, throw it over there, over there, over there. All right, thank you. This one doesn't want to go away. I had too much fun doing this stuff. And then I take this number and I bring it down here. And I take this number, and take that one and I throw it over there, oh, over there. Oh, come on. There we go. And then I take this one and I bring it down. So you see, all I'm doing is using the same values, 1/2, 1/3, but instead of using the 1/2 and 1/3, I am using these numbers that I just had over here and right here. Because now those two numbers have the same denominator, the same bottom. Once they have the same bottom, I can just add the top and I get 5/6. Wow, we just got a common denominator and it makes sense. Who knew math made sense? So, you may have heard this before, and these are all the rules. And we mentioned in the previous section here that when we have some number multiplied by 1 is the same number, and then 5/5, or in other words, the number on top of the other number that are the same, is equal to 1. So this is really key in defining common denominators, because you may not have this technology when you're doing a test to draw circles and do all those kinds of things and those kinds of things, but there's a way we can change them. So, for example, to go from here to here, what do I have to do? I'll take this one, multiply it by 3/3, which is equal to 1, as you know now. And then multiplying is easy because you learned about it back a second ago. Back here, it's top times top, bottom times bottom. And then I just go 1 times 3 gives me 3. And 2 times 3 gives me 6. So this turns into this. Same value, same shaded area, but it's the denominator or bottom that we're looking for. Wow, who knew that was so easy? Down here, take this one here, multiply by 2/2, which again is multiplying by 1, so the value doesn't change. But the fraction looks different because it's 1 times 2 gives us 2, and 2 times 3 gives us 6, and those are the numbers we're looking for. Here we go, and these ones come down. And now they are part of our new question, new equation, and it's easy to add. Perfect. And that's about it. Fractions are so hard. In any case, have a look at this. Please feel free to tell me what you think about this, and if you need any more explanation, let me know. Thanks. Bye.